Fundamental Theorem of Calculus Part 1 says that the derivative with respect to x of the integral from a to x of f of t dt is equal to f of x. That the derivative and this integration up to a variable are inverse operations of each other, and that they're antiderivative and derivative. You come back to what you started with, but not quite what you started with. I guess you got the variable plugged in. There's some variations on the theme that I want to take a look at here. For instance, what if you, instead of having the x as the right-hand endpoint, what if you had it as the left-hand endpoint? So what if you looked at the function from x to b of f of t dt and said, hey, what's the derivative of that? Well, we know that reversing the order of integration throws a negative sign in front, and so we might suspect, and this is true, that this is just minus f of x. Now I actually see this, let's draw two pictures here. If this is your function, and on one of them you're integrating from a to a variable x, and the other one you're integrating from, x to a variable, from a variable x to a fixed b, that is, when you're asking about a derivative, you're asking about how is this function changing. So if I change x and make it bigger, right, I have a positive function drawn here, but if I make x bigger, then the area is getting bigger. And if I make x smaller, then the area is getting smaller. But on this one, if I make x bigger, then the area between x and b has just gotten smaller. So this is doing the opposite of what that first one was doing, and hence the minus sign. Now, there's also a matter of using this derivative rule. The fundamental theorem of calculus is just a derivative rule for this new type of function. This now works in conjunction with all the other derivative rules you did learn from Calc 1. For instance, if I said I want the derivative with respect to x of x squared times the integral from 7 to x of t plus 2 to the t dt, I'd say, well, wait, I got a product of two functions here. I got x squared and I've got this area function. And so by the product rule, I'd have to say it's the first function times the derivative of the second function. Now, what's the derivative of this area function? Fundamental Theorem of Calculus Part 1 says just plug the x in. So the derivative of the second part would be x plus 2 to the x. So that was first times derivative of the second, plus the derivative of the first times the second. That derivative rule plays nicely with all the derivative rules we had before. Right? One variation that you'll see in the homework is the chain rule. What if I did something like this? What's the derivative with respect to x of the integral from, I don't care where, 0 to x squared of sine t dt? Okay. Now, I'm going to do this two ways. Right? One way is thinking in terms of the chain rule. That what I have here is I don't, normally I just have an x there, but I've got some function of x there instead. I've got an integral from 0 to u of sine t dt, where u is equal to x squared. So when I ask, what's the derivative with respect to x of this? Well, there's a chain rule that says, well, to take the derivative with respect to x, you first have to take the derivative with respect to u, but then multiply that result by du dx. Right? Well, the thing is, with respect to u, with a u there, this looks just like the first part of the fundamental theorem of calculus, using u as the variable instead of x, and so this should just be sine u. But then you got to multiply by du dx, which in this case, the derivative of u with respect to x is 2x. Plugging the u back in, I've got sine of x squared. I'm going to write the 2x out in front just so that it looks better. Right? So looking at the net result, I can say what happened. And I don't think I can get this all on the same screen at the same time unless I change my zoom by a little bit here. Does it work? Huh, maybe it did. Yeah, what did I do? The x squared ends up being plugged in for t, and then I multiplied by the derivative of the x squared. Right? That is, just thinking in thinking in terms of the fundamental theorem of calculus. It says take the derivative of the outside function, chain rule and the fundamental theorem of calculus. Chain rule is take the derivative of the outside function, leaving the inside alone. Well, that's this part right here, because the fundamental theorem of calculus says, what do? You just plug the variable in. Whatever was there, you plug it in for t, right? And you leave that inside alone. That was an x squared. It's still an x squared. Then the chain rule says, now multiply by the derivative of the inside. And so there's the derivative of the inside, 2x. Now I said I was going to do this two ways, and I will, right? So let's do this one again. We've got the derivative with respect to x of the integral from 0 to x squared of sine t dt. The thing is, I can actually figure out what this function is before I take the derivative. So I'm not taking the derivative yet. I'm going to figure out what this function is. By the second part of the fundamental theorem of calculus, I can just find an antiderivative. And I know the antiderivative of sine t is minus the cosine of t. And then I'm going to evaluate that between 0 and x squared. So what I'm looking at here is I'm going to want the derivative of, I'm still figuring out what this function is. I got minus cosine of x squared minus, so that becomes a plus, a cosine of 0. One of the things I like about this way is that it answers a question in my mind about why does it not matter what that constant is down there. And the thing is, when that constant's there, you can see that you just plugged it in, and now I got the cosine of 0, which happens to be 1, but whatever it is, it's just a constant. The variable's here, okay? And notice as well that the t disappeared. As soon as I took this antiderivative and then plugged in the endpoints, I don't have the t in there anymore. I've got the x squared in there. I've got the 0 in there. So, now I'm ready to take a derivative. How do I take the derivative of minus the cosine of something? Well, the outside function is negative cosine, so the derivative is the sine of that something. Leave the inside alone. But then multiply by the derivative of the inside, and then plus the derivative of this constant, which is 0, and we get to the 2x sine x squared. Okay. The constant doesn't matter because the only difference the constant makes is it's giving you a different antiderivative, right? If I had the cosine of 7 here, or the cosine of 15 here, or the cosine of anything else, it's just adding a different constant on. So I'm not changing the main nature of the function, I'm just changing how high or low the graph is, right? The derivative is still the same. So anyway, there's a couple of wrinkles that you'll see with dealing with the fundamental theorem of calculus in terms of mainly the chain rule here, and just to point out that, you know, it is a derivative rule. Fundamental theorem of calculus part 1 is a derivative rule, and it plays nicely with all the other ones. Right? All the other derivative rules, it still works. So anyway, there you go, fundamental theorem of calculus.